Howdy, AP PreCal. It is Miss Kosh. I wanted to make this video. This is one of our example problems that I had written. I think this is from the Harmonic Motion practice. And I had a number of kids ask me about this one, and so I want to try and explain it in a way that maybe I haven't yet. So here we go. The daily temperature in the month of March in a certain city varies from a low of 24 degrees to a high of 40 degrees. Okay, that's not Texas, but whatever. Find a sinusoidal function to model daily temperature and sketch the graph. Let noon correspond to t equals 0 and assume the day is warmest at 6 p.m. Okay, so what I would do is, well, first turn on my Apple Pencil. Let's see if this will work. There we go. Is we're going to say that at time equals 0, it's noon. The day is the graph. I'm sorry. The day is the warmest at 6. And so we're going to be here, and then we're going to come back, and then we're going to be however our coldest is and come back, something like that. Okay, so noon, then 6 p.m., so this becomes midnight here. I might write midnight, whatever. And then this would be 6 a.m., and then here, again, it would be the last point there is noon of the next day. Okay, so when I'm worried about my plants when the temperature, which is really true, is 28 degrees or colder. Actually, I'm worried about my plants when the temperature is 40 degrees or colder. But that's ridiculous. Okay, so it's a high of 40. It's a low of 24. And then, oh, that's not the low. The low would be down here somewhere, so figure not drawn to scale. Halfway between those, let's see, that's a total distance of 16, so 8 units away, so this would be 32, right? 24 plus 8 is 32, 32 plus 8 is 40. Figure not drawn to scale, so sorry. Okay, so here's our graph, and my kids have done a pretty good job of writing, let's see, Ms. Kosh, let me make sure I'm doing this correctly. Let noon correspond and assume the day is the warmest at 6 p.m. Yes. Okay. So we return back to that. Yeah, it gets cold through the night. Yes, all that makes sense. Okay, so our period here is a 24-hour period. So then we can say 2 pi over b is equal to 24. I therefore get b is equal to pi over 12. And so what's my amplitude? My this is my let's call it f of x is equal to, our amplitude was 8. This looks like a sine curve to me, and I see pi over 12 times x. There was no shift left or right, but there is a shift up 32. Okay, so here is my equation. And we want to know, when is the temperature 28? Well, 28 is somewhere in this region. So we want to know this time to this time. Okay, when should I be worried? What time of day? Well, let's set this equal to 28. So I have 28 is equal to 8 sine of pi over 12x plus 32. Okay, I subtract 32, I get -4. I divide by 8, so I just had -4 over 8, which is -1/2, is equal to, if you can do both of those steps at the same time, rock and roll. Okay, and so here is, and I'm going to erase that. Okay, here is what my kids were confused about today. They said, oh, I need to take the inverse sine, and the inverse sine of -1/2 would be equal to, so I'm taking the inverse sine of both sides, and I'm left with pi over 12x. Well, I know, since the inverse of sine lives between negative pi over 2 to positive pi over 2, on the unit circle, that a sine of -1/2 means that's, I went over a lot, and sine is the y value, so this becomes a negative pi over 6. And they're like, well, Ms. Kosh, how come you got, so then they said, oh, well, this is the only correct answer would be negative pi over 6 is equal to pi over 12x. Then I would multiply both sides by 12 over pi times 12 over pi. Things cancel, and I'm left with, at time, -2. So -2, what does that even mean in the context of my problem? Well, not a whole lot. I mean, it means that I found the answer over here on my graph. But I want to know during the day, where is it, and all that kind of stuff. So here's kind of what's happening. What we really need to do is say, coming back to this point right here, or from that point, when I have -1/2 is equal to sine, oh, that was weird, sine of pi over 12x, I want to think unit circle, and I want to think, well, when does sine of x equal -1/2? Well, the first positive answer is 7 pi over 6. The second positive answer is 11 pi over 6. So I'm going to say 7 pi over 6 needs to equal pi over 12x, and 11 pi over 6 needs to equal pi over 12x. And then what do? Multiply by 12 over pi. That gives me 14. And that gives me 22. What does that mean? It means 14 hours after noon. I don't think in terms of 14 hours after noon. 12 hours after noon would be midnight, so this is 2 a.m. And then 18 hours after 6 a.m., 4 hours later is 10 a.m. Or 2 hours before noon. That's a better way to think of that. This is 10 a.m. So I'm nervous about my plans from 2 a.m. to 10 a.m. I think that's what I put on my answer key. I didn't look, to be honest with you. But here's the takeaway for us. Okay, let's go back to algebra for just a second. If I were to give you something like f of x is equal to x squared, or I was going to give you something like g of x is equal to the square root of x. Okay, if I say find x when f of x equals 16, you may remember this graph has two answers when we set it equal to 16. It has one here at +4 and it has one here at -4. Okay, so I like to do the cheer, square root, plus minus, and I would say that f of x equals 16 implies that x, that's that little arrow means implies that x has to equal plus or minus 4. But it's a different question. Hopefully that's clear. It's a different question when I say find g of 16. That's saying g of 16 is saying take the square root of 16, and it's only 4. It's only the positive answer because our function, the square root, the function g of x equals the square root of x, looks something like that. When I plug in 16, I have this point 16, 4. That's it. I'm done. I only have one answer to that problem. Okay. So the way I like to think about it is when you are introducing the square root. So we came over here, we had like x squared equals 16, and we wanted to solve it, so we went square root, plus minus. When you do something like that, you get two answers. You get multiple answers. When you were given the square root of 16, that has exactly one value, and it's 4. In the trig world, what we're saying is, if I start with f of x equals sine of x versus g of x equals arcsine or inverse sine of x, these are different scenarios. My f of x here looks forever, right? It goes on forever and ever and ever. Well, if I want to know, find x when f of x equals -1/2, we have infinitely many answers. This is going to look funny. My graph is terrible. But can you see, well, if I drew it correctly, you would see that every period I'm getting two answers. Why is that? Well, because I can go around my unit circle as many times as I want. Anything that is coterminal to either -pi over 6, 11 pi over, well, which is 11 pi over 6, which I can add 12 again. I'm at 23 pi over 6. I have infinitely many answers to that. This one was 7 pi over 6, or it could have been a -5 pi over 6. Add 12, again, my brain is tired, it's the end of the day. 19 pi over 6. I have infinitely many times when this happens. And over here, however, inverse sine of x just looks like this one little piece. And so if I'm saying what is g of -1/2, g of -1/2 means, well, here's when x equals -1/2, we want to know, we've only got 1 point. And so this is that -pi over 6, and we're done. That we're finding this would be the point, -1/2 comma -pi over 6. Okay, so the takeaway is that when you are introducing the process of taking the inverse of the sine, cosine, or tangent, all of this was sine, but it applies to the others as well. What you may have infinitely many answers. When you look back to this particular, where did my scenario go? The answer we get if we're just working with the inverse sine world over here, the answer we get there doesn't make sense in the context of our problem. So we have to think back to the unit circle and what makes sense there. Hopefully that helped. So So if they give you inverse sine, not that you're taking the inverse of the sine, but if the problem has inverse sine, then that has a limited domain and range, limited range actually, and so that's where you have to only live between negative pi over 2 and positive pi over 2. Hopefully that helps. Let me know down below. Like, subscribe, comment, and keep watching videos. And of course, you can't learn math without practicing. Good luck.